Okay. Wow, that's loud. Just promise no feedback. Okay, good. All right, welcome after lunch. You're going to have to ask the first question since you're the first one late. So we have just two speakers today, and I'm going to add some slides myself. There's a lot of things that need to line up for chemical recycling, and one of those is offtake, and one of those is just getting your system running. Like Andrea says, like the big elephant in the room in financing is, does your stuff work? So that's a huge focus. That's been a huge focus of a lot of us in chemical recycling. The leaders who are just emerging or emerged over the last couple of years, they've been at it for 22, 25 years. Yeah, so we're really working out that the off-takers are really, really hungry for pie oil more than any product I can ever imagine. But the thing is they're tired of doing prepaid agreements. They're tired of doing financing of pyrolysis companies. So the big thing now is just getting the technology working. So the very next thing after offtakes lined up and the technology is working, you'll see 2 or 3 of us emerge this year with real production. Is feedstock, and people talking about feedstock is everywhere. Plastic is everywhere. There's so much of it. Don't worry about it. That's what the first few years were all about. Cyclix is one of the companies that realize it's super challenging and there's a big gap there. The question is, and we'll get to it, is what is, with a stack of all these companies needing margins and so forth, how does it become economic in the end? So first of all, let's figure out how to do it right, and then second of all, how do we make the economics work? So there's a lot of us running business models at the core of this, and we'll talk today about how to do this. There's different views about feedstock if you're a big player like a Baytown pyrolysis company, or like a New Hope, where they're trying to do 400, 500 tons per day, 1,000 tons per day in Baytown. A couple of us here, Kevin DeWitt and myself, we have companies that are doing decentralized pyrolysis. So that means you take plastic, right here, taking the process to where the plastic is. It's a lot more efficient, and we'll show how that affects feedstock and the whole business model. When you do that, you actually have different requirement for the feedstock provider, a feedstock prep. So if you were getting pellets from somebody to run in your decentralized pyrolysis system, you want small solutions. You don't want really big solutions if you're decentralized. So because we're doing like 20 tons per day or 40 tons per day, and we want a matching system to go with that. So since there's only two speakers and myself, I will talk a little bit about Resynergi, and then I'll introduce the speakers and we'll move from there. So, where's it go? Okay, so a little about Resynergi. I said we're decentralized. Being decentralized, we take our plastic to where the MRFs already collect. So the MRFs are collecting all day long just for us. So we don't have to collect the plastic, but we co-locate where our ecology is or waste management. When you're doing that, that means you're close to neighbors. I'm really tired right now because last night I was up till 1 a.m. with the town hall meeting with neighbors who were really concerned and had a million questions about when you put this in a neighborhood or near a town. So we're all about educating people that are friendly, safe, and clean. Now that might be sound too ideal, but that's what we really aim to do. This is the size of a semi-truck, the bed of a semi-truck. So we aim to provide great industrial jobs, to do it with a very small footprint and convince neighbors that we are a very small greenhouse gas footprint. There's no hazardous waste. We have source separated plastic, which means we don't have to wash our plastic. So we keep the site really clean from a water standpoint, runoff standpoint. We try to simplify this big time for the neighbors. The VOCs are equal to a car driving down the road on one of these 5-ton per day units. And the greenhouse gases are equal to a semi-truck. So they seem to relate to that, but we just need to keep driving home and convince them that's true with real data. So anyway, we're very, very community focused, and we're really good at getting all the politicians and so forth close to what we're doing and supporting it. So what makes this all possible is small modular. What we use as technology is microwave. So it's ultra fast. So it's about 100 times faster than a typical pyrolysis. So at any one time, because we're 100 times faster, we have just 1 kilogram roughly of plastic in our reactor at any one time. So that just goes really fast through the system, and we can have, it's about this diameter and 3 feet tall, our reactor, actual reactor. So we can go into very small places and be 5 tons per day in a very small footprint. I guess it was a year ago today, we talked about shipping our first tanker of oil, and then with a single reactor. Now we have the four reactor, 5 ton per day system up and just about to turn on. We're waiting for our permit any day. So it's 30 to 45 days and we'll have that permit. But it's all drafted and so forth. But we had to jump through hoops. We had to get UL listing on the whole thing. We had to do all kinds of things for AQMD, the air quality district. So this is that first unit, 4 reactors on a skid, does 5 tons per day total. We'll be able to keep the system up running and rotate the actual the maintenance. So we'll have 1 reactor down on occasion, so just rotating through to keep the whole system going. So what we've done is we've turned the whole model around. Like, so oil and gas industry is so used to having everything centralized like a refinery, collecting all the feedstock or drilling, bringing the crude there, and then refining in one central location. That doesn't work for plastic because plastic is so expensive to actually transport. So what we do, flip it around. What is the most cost-effective way to make a product? It's mass production. But what oil and gas does is they make every single product, a refinery, they do that on a customized basis. Every single one is customized because they're centralized at a different location. We put the entire plant on a skid, and that skid is mass produced. So that's the lowest possible cost for the plant. And then decentralized deployment, because we bring the process to where the plastic is, there's no shipping cost for the plastic. So it seems obvious to do, but it's not if you're from oil and gas. So what this also means is it's ultra fast deployment, because these can be actually inventoried and delivered as soon as the site is prepped and ready and turned up. And then you can turn it up really quickly. So what we can do, so most of our sites are going to be close to where the, what happened to that? That's a ginormous, big plant with about 70 of our modules. Just that went away in the slide somehow. But just imagine like 50 of those modules put together in the desert. Some countries internationally, that would be more common, but in North America, we plan to be located close to a lot of MRFs. Now, what does it do, the economics? This is real simple. This is taken from the AMI conference in Dallas. This is ultra poly slide. They lined up all the touch points of preparing feedstock. So in yellow is where you're transporting. So you're trucking to a site, and then you're trucking to a pyrolysis. So on the far left there, you have the MRF, or wherever you're getting your waste. So say you got film bills, you don't have to pay for it. It's free because it's real expensive for them to landfill. So they may pay you some money or give it to you free. And then you got to get it from wherever that is to your processing plant, your plastics, your prep site. Do the shredding, cleaning, shredding, all your different steps, and then you got to ship it to the pyrolysis plant. But if you have everything in your pyrolysis plant right there at the MRF, You get rid of those two yellow trucking points, and if you have a really good relationship with the MRF, they'll actually pay you to take the plastic. So imagine the yellow going away, and that 0 for waste generation is actually a negative number. You can save over a third if you co-locate where the plastic was collected. And that's just what this slide shows. Those two yellow spots, those would go away, and you'd go from 33 cents down to 23, and then even less because they're paying you a little bit. We're getting paid because it costs almost $200 to landfill if you include transportation. By Recology up north and others up north in Northern California, it's somewhere between a third and a half they pay us to take the plastic. So that won't be forever, but it's nice, and it will be for some time until there's a lot of pyrolysis plants. So even better is not film bales, but mixed rigids that are hard. They just have one step, which was the grinding, shredding. There's no cleaning, there's no densifying into pellets. So if you take the yellow out, you're taking out 40%. And if you're that waste generation, there's more value in that, but usually those mixed rigids are almost throwaway as well, and they'll almost give that to you free, and you don't have to pay for that. But in any case, the summary here is that working at decentralizing and locating at a MRF, you can save over a third of the prep costs. And if you're good with your negotiations, and because we're early in the industry and everybody wants to be first, there's enough people who want to be first on this, you're able to get actually paid for that generated plastic. So with that, that backdrop, I did want to say something about the plastic for mechanical recycling, which is the history of plastic prep. Has been all about how clean can we get that plastic. So we get plastic that's super, it's all over the map, so but 1s and 2s are largely recycled, but there's a bunch of steps to get that really clean and sold as pellets. Mechanically recycled, not broken down. It's very different in the chemical recycling world in a sense that you don't need it to be clean. In fact, you want the cost as low as possible, so you're wanting it to be as dirty as your system will take. And because these systems usually break things down and take the dirty stuff and make it into char, you don't need to clean, you don't want to pay those extra costs. So there's a lot of effort to optimize for that. The second optimization is for low footprint, because if you're decentralized, you don't need a big plant. You want something that works really well for 20 tons per day. You don't need a 100,000 square foot plant. You want a very small footprint and a small cost. So it's really counter to the traditional mechanical recycling prep of feedstock. So with that, I'd like to introduce our first speaker, Leonard Benfeld of E-Factors. E-Factor 3.